Hi, welcome to this demo on DB2 HADR. In this discussion, we will be talking about how IBM DB2 HADR has been used at a customer location wherein two banking customers are sharing their DB2 infrastructure with each other. We will be discussing about what is HADR, how to initialize the HADR, how to monitor HADR, do the takeover operations, then we'll be concluding this particular demo. High availability disaster recovery. DB2 Data Server High Availability Disaster Recovery feature is a database replication feature that provides a high availability solution for both partial and complete site failures. HADR protects against data loss by replicating data changes from a source database called the primary to a target database called the standby. The standby database is kept in sync with the primary database through log data that is generated on the primary and shipped to the standby. The standby constantly rolls forward through the logs. After the failed original primary server is repaired, it can rejoin the HADR pair as a standby database. If the two copies of the database can be made consistent, after the original primary database is reintegrated into the HADR pair as a standby database, you can switch the roles of the databases to enable the original primary database to once again become the primary one. Setting up of HADR. It involves setting up of various configuration parameters on the intended primary machine, take a backup of the intended primary, create the standby by restoring the backup image, set the configuration parameters on the standby machine, start the HADR, confirm that HADR is up and running, and perform a takeover operation. Configuring the HADR involves modifying the parameters specific to the database on the primary and the standby machines. The configuration parameters are log index build, the HADR specific parameters on both the machines. We will see in this slide how do we have just created a database, a primary machine, update the configuration parameters using the update dbcfg command from the db2 command prompt. We will also update the other parameters using the update dbcfg command. We are done with the updation of the commands. HADR synchronization mode specifies the degree of protection of the DB2 high availability disaster recovery database solution has against transaction loss. The first mode is sync, which also means synchronous. This mode provides the greatest protection against transaction loss, and using it results in the longest transaction response time among the four modes. In this mode, log writes are considered successful only when logs have been written to the log files on the primary and when the primary database has received acknowledgement from the standby that the logs have also been written to the log files on the standby. The log data is guaranteed to be stored at both the sites. Near sync, which means near synchronous. While this mode has a shorter transaction response time than synchronous mode, it also provides slightly less protection than against transaction loss. In this mode, log writes are considered successful only when the log records have been written to the log files on the primary, and when the primary has received acknowledgement from the standby system that the logs have also been written to the main memory on the standby system. Loss of data occurs only if both sides fail simultaneously and if target site has not transferred to non-volatile storage all of the log data that it has received. In the async mode, compared to the sync and async and near sync modes, the async mode results in shorter transaction response times but might have greater transaction losses if the primary database fails. In the async mode, log writes are considered successful only when the log records have been written to the log files on the primary and have been delivered to the TCP layer of the primary system's host machine. Because the primary system does not wait for the acknowledgement from the standby, transactions might be considered committed when they are still on their way to the standby machine. The next is supersync. This mode has the shortest transaction response time but also has the highest probability of transaction losses if the primary system fails. This mode is useful when you do not want transactions to be blocked or experience elongated response times due to network interruptions or congestion. In this mode, the HADR pair can never be in the pure state or disconnected pure state. The log writes are considered as successful as soon as the log records have been written to the log files on the primary database. Because the primary does not wait for acknowledgement from the standby system, the transactions are considered committed irrespective of the state of the replication of that transaction. Creating the standby. Take a backup of the primary machine, backup the image to the standby system, configure the standby system using the update dbcfg commands. We will show a small demo on how to do this individual task. The first command, we do a backup of the primary database. Then we copy over the backup image to the standby machine. Then do a restoration of the image on the standby system. And then update the dbcfg configuration parameters. Starting the HADR involves a two-step procedure. Start the HADR on the standby machine and then start HADR as primary on the primary machine. We make use of the db2 command prompt again to start the database as standby on the standby machine. Then issue the start HADR as primary on the primary machine. Once these two commands successfully complete, the primary and the standby databases are configured as HADR systems. Monitoring HADR. Once successfully set up, it might be required on an ongoing basis to monitor the state of HADR. We have multiple options in IBM DB2 to get the status of the current HADR system. We can make use of the table function called as monitor get HADR. We also make use of DB2 problem deterministic tool called as the DB2 PD and use it with the -HADR option to look at the current status of the HADR. The information that we primarily look for are the state, the status, the heartbeat interval, the HADR log gap, and the standby receive replay gap. These are some of the parameters which we monitor as part of the monitoring process. We will issue the DB2PD command with HADR, and we can have a look at the HADR state. The HADR connect status, it's shown as connected, which means that the primary and the standby are communicating with each other. Time since the last receive from the primary to the standby, the last gap between two communication, and the HADR log gap. It basically means the LSN gap between the primary and the standby. Takeover operations. We have multiple options to do a takeover of HADR on the primary and the standby. We can do a forced takeover. We can do a graceful takeover of a role switch, do it manually using the takeover HADR command, or we can also make use of a cluster manager software like TSM or TSA. We see that the HADR role is currently standby. We do a takeover HADR on this system. And once we execute the DB2PD, it will then show the HADR role as primary. So the standby has been now made the primary. The HADR role on this system is standby. We do a takeover HADR on this system and then execute the DB2PD command. It will show you the HADR role as primary. So now with these two commands, we have switched the roles of the two systems involved in the HADR configuration. For JSB and DNS Bank, we had used the HADR in conjunction with the Tivoli system automation cluster domain, wherein both the banks were having their databases on a common DB2 instance. You can see that they were making use of a shared storage, and the HADR standby server was on a different machine, which on a DR site around 150 kilometers away from Pune. And both these systems were kept in sync with each other using the Tivoli system cluster. If any one of the nodes in the cluster failed, it will automatically fail over to the next node of the cluster. And if both the nodes have failed for some reason, the HADR will then take over the activity on the standby system. Using this process, both the banks were able to maintain and adhere to the disaster recovery policies without having to invest a substantial amount in having individual data centers for themselves. So this is a new paradigm in low-cost market wherein banks do not have the infrastructure, nor do they have the revenue to maintain separate infrastructures. So this is a new way of sharing data centers. Hope you enjoyed and liked this demo. Thanks a lot for your time and have a good day.